Let's learn how to write some code in our programs that allow them to behave differently based on inputs. For example, what if we wanted to make a game where, let's say I'm holding up some number of fingers behind my back, and I ask you to guess how many fingers am I holding up? And let's imagine you guessed 4, but I was holding up 3. I would say, sorry, you guessed incorrectly. Let's imagine instead a different take of this, where you had guessed 3 and I was holding up 3. I would say, wow, you guessed correctly. And notice my behavior changed depending on the input that you gave me. How can we emulate this kind of behavior where we have a different outcome based on information that's being given to us as input? Well, in programming, these are called conditional statements. And in most programming languages, they have some construct called an if-else, and we'll learn some variations of this later as well. But if-else statements are sort of the bread and butter, and this is true in the Python programming language as well. So in this video, we're going to learn the basics of if-else statements and how to use them in order to write programs that behave differently based on the inputs that are given to us. So let's talk about the purpose of these if-else statements. When we think about our programs, we like to think about something called control flow. And control flow is the idea of how does the computer decide what to do next? What comes next? What happens next? And the idea is, so far we've seen our code runs linearly. Right? So we have a statement on line 2 that's evaluated, and then there's another statement on line 3 and that's evaluated, and then another on 4 and that's evaluated. And so we have, if we were to try and visualize this, we have this control flow where, let's say the computer moves to the next line, that's some line of code, we move to the next line, that's some other line of code, we move to the next line. And this is our default, operating mode where we're just moving line to line to line. And maybe I'll label this line 1, line 2, line 3. And this is the standard flow, or standard mode of control flow. What if we wanted more control? What if we wanted to be able to have effectively like a fork in the road where we go in one direction or another based on some input? And how might we visualize this? Well, for something like that, we're going to use a conditional statement. And the way it's going to work is something like this. In this example that we're building up, let's imagine that we are asking the user for input. So what's your guess? What guess? Right? And so this would be us asking for some input. We'll use the input function to do this. And again, I'm going to write in English here what's going on at each of these steps, and then we'll look at how we translate this English into code. And then we reach a decision, and this decision is what's important. And the decision is going to ask, in this game, does guess equal, and I'm going to use the double equal symbol here, secret. And this is a question, right? So this is a question we're asking. Does the user's guess, is it equal to the secret that I was thinking and holding up the number of fingers behind my back? And if so, let's say here in the true case, so if so, what we're going to do is we're going to print correct. You win. Right? So this is one place that our program might continue on to. And if it's incorrect, right? So if the user had instead guessed false, then we would print a different message, wrong. Right? Now, after either of these, we might print a message that says thanks for playing. So each of these would continue on after this in our program. And so notice that this visualizes quite differently from the way we were thinking about our programs working before. Before we go line by line by line, and we have this linear, very predictable, very orderly process. And here we still have a very predictable process, but our program can go in one of two places, right? So when we ask the user for a guess, we test it and we see, hey, is this a correct guess or not? So there's some condition here. And that condition is why this construct has its name. This is a conditional statement because based on the condition here, is the guess equal to the secret? Yes or no, true or false? True, we're going to do one thing. False, we're going to do something else. And then our program will continue on. Great. So now that we have a fundamental understanding of this, let's try actually implementing this very simple game in code, and then we'll look at the syntax and break that down a little bit more specifically after we've seen it in action. So I'd encourage you to join me in VS Code, and I'm just going to make a new file in my lessons directory, and I'm going to name that conditionals.py. Okay. So once again, if you are following along, one of the ways you can know which directory and file name I'm working on is looking in this area of VS Code. This will be the directory, and there might be multiple directories here, but here I'm currently using just the lessons directory, and then conditionals.py is the file name. All right, so let's go ahead and add, for good measure, a doc string here that is to say something such as an example of conditional if-else statements. Okay. Now, let's set up a variable to hold the number that we're thinking of behind our back. So I had used 3 before, and so I'm going to call this secret. And secret is going to be an integer that is 3. Okay. You might be wondering, why did I choose an all capital variable name? Don't we tend to call our variables by lowercase names in Python? Well, this is going to be a special kind of variable, and if you notice, if you hover over it in VS Code, it's recognizing it as such. And when we name a variable with all capital letters, it's one that we're intending to be a constant, meaning we don't actually plan on changing this value later on in our program. We're saying for the purposes of this program, we want this value to always be 3. We're just putting a number, or a name, to some special, what we call a magic value that otherwise doesn't have meaning. Anyway, that's not why we're looking at this, so let's continue on. So let's set up a value like guess. And guess is going to be a regular variable, and we'll ask for input. And the input will be, what is your guess? And you'll notice that I have, because we're using Python's type annotation, so we're saying guess needs to be an integer variable. And we're using a special plugin in VS Code called Pylance that tests and makes sure, like, hey, does your program actually make sense? And here it doesn't make sense because the input function returns a string and evaluates to a string value. And we're trying to assign a string to an integer variable, and we can't do that. So we first need to convert that string into an integer, and then we should be able to continue on. Now, if we were to run this, all the user would see is, what is your guess? And they wouldn't have a sense of, well, what am I even guessing at? I don't know. So let's print a value. I'm thinking of a number between 1 and 5. What is it? Let me make this a little bit larger. There we go. And notice that our program so far is working in the standard flow of control, where we evaluate this doc string. A doc string doesn't do anything. We evaluate this variable declaration. This sets up a special kind of variable, a constant named secret. And then we print out, I'm thinking of a number, and then we ask the user for an input. What is your guess? And now we want to do this test. We want to conditionally check and see, did the guess equal the secret? Okay, so how can we test that? Well, here's where we're going to see our first if then else statement. So if is a special keyword in Python. You can't use it for anything else. You can't use it as a variable name or any other kind of name. It's reserved for only the Python programming language's purposes. And notice you get a different syntax highlighting color indicating that this has some special meaning in the language. So if guess is equal to secret, colon. Notice that we have a test here, and this is a Boolean expression. We're using the relational operator is equal to, and we're testing, is the guess equal to secret? And then this colon is saying, okay, that's the end of my condition. And on the next line, following one level of indentation, that's what the computer is going to do if that evaluates to true. Okay, so if guess is equal to secret, then what do we want to do? We want to print, you guessed correctly. maybe a few extra exclamation points. It's a very exciting outcome. And for now, before we go and add what happens if you guess incorrectly, I want to just demonstrate the simplest form of an if statement. And then let's print game over, right? Notice that I printed game over at a level of indentation that was at the same level of indentation as, say, our if statement, all right? And if I use my pen here, I can highlight. Notice that VS Code is drawing in this little line here. And then this line is indented by one level. And this is important. This has significance. What we're saying is after this if test, then what we're going to do is everything that's indented by one level, just following it, right? And we'll expand on that in just a moment. So let's try running this program and seeing what happens, okay? So I'm going to open up my terminal in VS Code. And let me see if I can get this all to fit on one screen. There we go. And I'm going to run Python module, and I'm in the lessons directory, and then I'm working on conditionals.py. So it asks us for a number. What is it? And I'm going to guess incorrectly, like we did in the example. So I'm going to guess 4 first. And it just prints game over. That's not a very nice program. We're going to want to go back and improve our program to make it a little bit nicer and say, oh, you guessed incorrectly. Sorry. Try running this program again. Okay. What if we had guessed 3 instead? So I'm going to try 3. And notice we get a different evaluation. We get a different outcome here. It tells us we guessed something correctly. And so our program behaved differently. It took this different line of execution and it decided, hey, because these two things were equal at this point of test, I'm going to go ahead, go into this, what we call the then block, as we'll see in a second. And then I'm going to print you guessed correctly. And after that, I'm going to print game over. Okay. Well, how can we have it say you guessed incorrectly? So if can be paired with a corresponding else statement. So else, and notice that the level of indentation here is back to the same as if. This is very important. If I had written my else statement here, notice I've got the red squiggly underlines indicating this is a syntax error. And if I were to highlight over this, Python doesn't even give us a very helpful error message here. It says expected an expression, which we know what an expression is, and else isn't an expression. It's a special kind of statement. But anyway, else needed to be at the same level of indentation as if, right? Now, everything we want to do, if we want to do something else, is going to be one level of indented following the else statement and its colon. And let's just print, sorry, you guessed incorrectly. Okay. Maybe a sad face here. This is a sad outcome in our program, all right? So notice now we have, if the user guesses equal to the secret, then we're going to print you guessed correctly. Else, you can think of else as otherwise, we're going to print you guessed incorrectly. And then we'll print game over either way, all right? And I know it feels kind of subtle, but it's super important. So important that I just want to emphasize this with pen one more time to appreciate that. Notice in the standard mode of operation in our program, everything was just at the same level of indentation, line after line after line. And then here, when we use this if-else statement, again, VS Code is trying to say, hey, here's a block, and this block is one level of indentation, and that's important. That's everything that's in this block that's the same level of indentation is going to be considered as belonging to that if condition, and then same with the else. Everything that's at this level of indentation will belong to the else and be done in only when that condition was false. Okay, so let's try running this. And actually, before we try running this, let me just expand on that real briefly and say, if we wanted to have a second statement that printed only when this guess was incorrect, we could also print, try running the program again. Otherwise, we could print, so another line for the guess, you guessed correctly, and we could print something like, have a wonderful day. All right. So notice that as I was mentioning, the indentation is important here. These two lines are indented the same amount, meaning both of these will belong to the then statement. So after a correct guess, we would print both of these lines out. First, you guessed correctly, and then have a wonderful day. Otherwise, sorry, you guessed incorrectly, try running the program again. Okay? So let's try convincing ourselves that this actually works. And let me just scroll this down a little bit. Okay. So I'm going to run my program again. And I'm thinking of a number between 1 and 5. What is it? Let's guess incorrectly. 4. And notice it says, let me make this a little bit larger. Sorry, you guessed incorrectly. Try running the program again. Game over. All right. So those two lines were evaluated. And if I were to scroll up even further, we could prove to ourselves, what is our guess? And then immediately, sorry, you guessed incorrectly. So we skipped over this then block, right? This didn't get evaluated because we didn't guess correctly. Similarly, if we had guessed correctly, notice that we guessed 3. You guessed correctly, which was line 9 being evaluated. Have a wonderful day, which was line 10 being evaluated. And then notice we didn't print, sorry, you guessed incorrectly, or try running the program again because it wouldn't make sense to. Those lines were skipped over and we jumped directly down to game over. Okay, so hopefully you're kind of getting the hang of this. All right, let's go talk about this syntax a little bit more specifically, and then I want to add one more piece of intuition to this. After this, I want to come back to the program and try making it possible for the game to give the user a little bit of extra feedback. So when the user guesses incorrectly, maybe we should tell them to guess higher or lower based on their input. So let's talk about this syntax. The syntax of an if-else you've just seen, and it starts with a keyword if. Right? So the keyword if is important. So if, and then what we're going to see following this if keyword, and actually let's make a note of this. This is important enough. Reserved keyword to start a conditional. Statement. Right? And this is the syntax of an if then else statement. Right? We'll see that this is a statement, as you just witnessed in the previous demonstration, that spans multiple lines of code. Okay, so if and then what? Well, if is going to be followed by a conditional, a condition. But not just any condition. I'm going to be very specific here. Actually, let's just write a condition, and then we'll write specifically what this condition must be below it. And that condition must be, and let's emphasize this, must be a Boolean expression. All right. So I'm going to just draw a box around this to indicate that this is sort of a, and let me make this, this is a placeholder, right? You're going to fill in the condition with something that is specific to the test that you're performing. In our example, the condition is the guess equal to the secret, right? In your programs, you can write any kind of Boolean expression here. And this is why expressions are so important to understand. What you're comfortable expressing in terms of something that can evaluate to a Boolean, and how might you compare two things to get a Boolean out of it, determines like the kinds of programs you can write and what conditions you can use to make decisions in your programs, right? And then we're going to have a colon, and that colon is required, right? So required colon after condition. I'm just going to shorthand this to cond, which is common in computer science. Okay, so if the condition, then what we're going to do is what we call the then block. Right? I'm going to use green to indicate the then block. And so a block is a sequence of statements, right? So we saw this as two, like a print statement and a print statement, but a block can also be made of any other value, any other kind of statement. For example, we could change a variable inside of a then block. We could have, we'll see another if then conditional inside of a then block. Any statement that we can make inside of the then block. But what's important is the then block is indented by one level, right? So every line in then block, and we'll see this is true of the else block as well, like we discussed, is indented one level, right? Okay, this is all that's required of an if statement. And there are some scenarios where you only want to do something if something is true, and you don't really care about doing something special if the value is false. For example, let's imagine you were trying to close a program and you had made some changes to some file. That program asks you, hey, do you want to save these changes? And if you were to say yes, ultimately somewhere in that program, there's a conditional that would say, did the user respond yes? And if so, let's do the work of saving their changed values to storage. And if you said no, it wouldn't really do anything. It would just say, okay, let's skip over the saving part and continue on. There are many other examples of where you might use an if statement without an else corresponding. Okay, so what we're going to see with this else is it's optional. And if you want to have some different behavior, if your condition was false, you can add an else that's corresponding to the if. Now I want to mention that the else statement has to be paired with an if. You can't have it just floating around in your program. You have just regular lines of code and then else. It doesn't have any meaning, right? The meaning of else is determined by the context of the if. And so we'll see that if this condition is true, we'll do what goes in the then block. Else, we're going to, if that condition evaluates to false, then we would do what's in the else block. And I'm going to use a more reddish pink color here to indicate this is the else block. And we can have statements inside of here just the same. Any valid statement you can write anywhere else in your program, you can write here in this else block. And I'm going to draw a similar arrow down to the else block, which also needs to be indented by one or a consistent amount with every other line in the else. Following this, after we're done specifying if something's true, do this, else do that, we would unindent and our program would continue on from there. Okay, so let's see, what else do we want to make notes of here? What I'd like to do is just very briefly diagram over here to the left how these pieces come together in that visual we started out with. So remember, we come into our program and something happened above this. Previously in our game, we'd asked the user for some guess, and then we reached this decision, right? So this decision is true or false condition, right? Is this condition, which must be a Boolean expression, right? It has to evaluate down and simplify down to either true or false. If it simplifies down to true, what do we do? Well, if it's true, we'll do the then block. Otherwise, if it's false, what we're going to do is the else block, right? Now, after the then block and the else block, both of these will continue on directly in the next step of the program. So let me actually get out of the way here, go to screen only. So after the then block continues, notice we're going to skip over everything that was in the else block, and we're just going to continue on to whatever comes next in our program. And same idea with the else. If that condition tests to false, we skip over the then block and we continue on in our program. Now I want to mention that the orientation of these blocks relative to one another is inconsequential. And the lines that I'm drawing here are kind of sloppy. Feel free to rearrange your diamond and your boxes, but your arrows are flowing in one direction here. And we're saying this is what happens next. This is what happens next. And this is what we mean when we say the control flow. It's what is the computer going to do next after the current statement evaluates. All right. So let's let's explore this idea a little bit further and say, okay, well, Chris, you just said that in this else block or in the then block, we can write any kind of statement we want. Well, an if-else statement is a statement. So can we put another if-else statement inside of an if-else statement to take some special behaviors? And yes, you can. So let's try and extend our game to give the user a little bit more context. And I'm going to actually delete the second print statement here. And let's test. Well, if you guessed too high, then we'll tell you you guessed too high. Or if you guessed too low, we'll tell you guessed too low. Okay, so if the guess was greater than the secret, we can print you guessed too high. Right? Otherwise, we can print you guessed too low. Okay? Now notice something very important is happening here. What we're seeing is this is the else block, right? So let me just highlight everything and let me use the same color here. So if I were to go to green for a second, let me do purple. So purple, that's too light. I'll use pink. So pink is, here's our condition. And also in the second if statement, notice here's the condition. So I'm just trying to point out the various parts of this. Notice what's true about both of these things is that they're Boolean expressions. In this case, they're both relational operations being carried out. We'll learn some more complex Boolean expressions we can write later. And then what we can see is, okay, well, this is the then block of that outermost condition, right? So if guess is equal to secret, this is the then block of this if else. I'll come back and talk a little bit more specifically about the if else here, but the else block is this one, right? Great. So in this else block, what I just said, you can write any statement you want, right? The same is true in the if or the then block. We could have written any statement we wanted there. We could have if-then statements in the then block too. No problem. Well, let's take a look. Okay, well, one of our statements is another if-then-else statement. And this is a really interesting concept that in programming we call the concept of closure. We're able to reuse an idea in terms of itself and as a part of itself. And so we can have if-else statements inside of if-else statements, and that's okay because they're just statements after all. And anywhere you can use a statement, we can use an if-else statement. So here we're saying if the guess is equal to secret, well, we've got, notice, another then block. And this then block, you guessed too high, only corresponds to this if else, this in the else branch, right? So none of this is going to be evaluated. Like we're not going to test is the guess greater than the secret if you guessed correctly to begin with, right? Because if this was true, we would jump straight over. We would print you guessed correctly, have a wonderful day, and then we jump to game over. All right. So there's one other else block as well. I just want to point out with some highlighting. So the else block here is you guessed too low. Okay. So let's actually try running this and seeing if this program behaves as we would expect. I'm going to hide these annotations for a moment and open up my terminal, run my program, and let's try guessing 4 again, which is a number that's too high, right? So sorry you guessed incorrectly. Notice we didn't, and if I were to scroll up just a little bit, so your guess is 4. Sorry you guessed incorrectly. So we skipped over the then block, right? We jumped because guess was not equal to secret. We jumped into this else and we printed, sorry, you guessed incorrectly. And then we tested, is guess greater than secret, which the guess was 4. The secret is 3. So that's true. Because that's true, we go into this then block and we print, you guessed too high. And notice that we're not printing, you guessed too low, because that wouldn't make sense in this program. And finally, after all of this is done, we continued to game over. Okay, great. Well, what about if we tried the alternative path and we tried with a guess of say 2? And now notice that we have a different behavior. sorry you guessed incorrectly. So we didn't print you guessed correctly, of course, because we didn't guess the secret. We guessed too low, and then game over. Okay. And lastly, if we try guessing correctly, it tells us you guessed correctly, have a wonderful day, and then it goes straight to game over, right? Notice we didn't do anything because this outermost condition was true when the program reached line 8. And notice we don't know whether it's going to be true or false because we're asking the user for some input. So this program, it depends entirely on what the user gives us as input. We can't know before this program runs what it's going to do exactly, but we know what it's going to do in either of these cases. If the guess is equal to secret, we carry out these 2 lines and then we print game over. Okay. Notice that the same rules of indentation continue to apply in what we call recursively, right? So everything in this else block needed to be 1 line of indentation. But one of those statements was another if else statement. So in order to continue following these rules, what we would say recursively, or applying them again after again, is we have to indent those blocks by 1, right? So this was the then block of the guess greater than secret, and this was the else block of that corresponding condition as well. All right. So this is your introduction to simple if-else statements in Python. And the big idea is that we're able to write code in our programs that behaves differently based on inputs. So much of what our programs do winds up needing to choose, do I go this way or that way in the program? If something's true, I'm going to do this, else otherwise I'm going to do that, right? And with that, we can start to write programs that behave dynamically, meaning when the program is running, it can behave differently based on stimulus or different inputs from the user or from other places as well. And that allows us to write more dynamic programs that are more powerful. In the next lesson, we're going to take a look at, well, what if we wanted to be able to loop a game like this and say, well, if you didn't guess correctly, ask again. Or what if we wanted to write a loop that tried running some calculation 100,000 times? How could we write a program like that? Well, stay tuned for the next video and we'll take a look. Great work.